Neanderthals were absolute freaks of nature. You are sitting on a padded bench inside a perfectly climate-controlled gym, staring at your reflection, while your wireless headphones blast music directly into your skull. Your workout watch says your heart rate is optimal. Your shaker bottle contains an exact serving of protein. Your training app says today is pull day, which sounds impressive until you remember that the heaviest thing you have pulled this week is an office door marked push. After 6 months of curls, supplements, meal plans, and motivational videos, your arms finally look slightly larger under the correct lighting. You feel powerful. Then the gym door opens. A Neanderthal walks in. He is not a 7-foot monster. He is probably shorter than you, but he is broad through the hips, shoulders, and chest. His limbs are thick. His bones developed under a lifetime of physical loading. His body looks less like a modern fitness model and more like someone compressed a heavyweight wrestler into a compact Ice Age frame. He looks at the cable machine. He looks at your shaker bottle. Then he looks at you with the expression of a man who has spent his morning carrying animal tissue across frozen ground and cannot understand why you drove to a building to move metal in circles. Would he break every world record in the gym? We cannot know. Fossil bones do not preserve bench press statistics, and no honest scientist can calculate exactly how much a Neanderthal could lift. But the anatomy tells us something important. Compared with most people living sedentary lives today, Neanderthals were extraordinarily robust, physically active humans. Their bodies were shaped by cold climates, heavy workloads, dangerous hunting, and hundreds of thousands of years of evolution in Western Eurasia. They were not invincible superheroes. They were not stupid cavemen. They were a different kind of human, built for a life that would make your hardest workout feel like stretching. And that is why calling them freaks of nature is not entirely wrong. The first thing we need to destroy is the old image of the hunched, shambling Neanderthal dragging his knuckles behind him. That stereotype was encouraged by an early reconstruction of an elderly skeleton whose bones showed serious age-related disease. For decades, the public imagined Neanderthals as crooked, half-ape failures, waiting for modern humans to replace them. Later discoveries made the mistake obvious. Neanderthals stood upright. They walked on 2 legs in a fundamentally human way. They made sophisticated tools, controlled fire, hunted large animals, cared for injured group members, and survived repeated climatic changes across Europe and Western Asia. But standing upright did not mean they looked exactly like us. A typical adult Neanderthal was short and stocky. Estimates vary, but many males may have stood around 164 to 168 centimeters tall and weighed roughly 75 to 80 kilograms. Some individuals were lighter, some were heavier. Their bodies were not made of pure muscle, but their combination of broad trunks, heavy skeletons, and powerful muscle attachments would have made them look extremely strong for their height. Their upper arms and forearms were robust. Their joints were large. The shafts of their long bones often show thick cortical walls and shapes associated with repeated mechanical stress. In plain English, their skeletons look like they belong to people who use their bodies constantly. A modern person may train hard for 1 hour and then spend the remaining day sitting in a car, office chair, restaurant, and sofa. A Neanderthal did not have a workout. The environment was the workout. Collecting fuel was a workout. Moving a carcass was a workout. Breaking wood was a workout. Digging through frozen ground was a workout. Making tools was repetitive manual labor. Walking across uneven terrain while carrying food, children, hides, stone, or firewood was simply Tuesday. Their proportions also helped them survive cold conditions. Shorter lower arms and legs reduce exposed surface area. A broad body retains heat more effectively than a narrow one of the same height. Their ribcage was especially unusual. Neanderthal chests were broad in the lower portion, creating a different shape from the narrower thorax common among modern humans. One study estimated that several Neanderthals may have had lung capacities around 20% greater than modern humans of comparable size and sex. But even this remains a scientific debate. The reconstructed skeleton of Kabara II suggests a lower chest that was wider, but not necessarily a larger ribcage overall. Soft tissues do not fossilize, so exact breathing performance remains uncertain. What is clear is that the Neanderthal torso was not the simple barrel chest shown in old cartoons. It was a powerful, broad structure connected to a heavy body with high energetic demands. Then there was the face. A Neanderthal skull looks dramatic because the face projects forward. The brow ridges are large, The chin is weak or absent, and the nasal opening is broad. But the brow ridge was not a built-in crash helmet. That sounds exciting, but there is no evidence that it evolved to protect the eyes from flying mammoth rocks or angry relatives. It was part of a larger pattern of skull shape. Their jaws were strong, but they were not casually chewing through large animal bones, like prehistoric hydraulic presses. Neanderthals used stone tools to open carcasses and smash bones for marrow, because stone is much better at that job than teeth. Their large noses are often described as biological furnaces that warmed freezing air before it entered the lungs. The real story is more complicated. Their nasal passages probably affected airflow warming and humidification, but scientists still debate exactly how their internal nasal anatomy functioned and why the midface became so prominent. This is an important rule when talking about Neanderthals. Their anatomy was impressive enough without inventing superpowers. Now imagine waking up inside a rock shelter 50,000 years ago. There is no alarm clock. There is only smoke. Cold air damp hides somebody coughing near the fire, and a hungry child discovering that your face is an excellent object to hit before sunrise. You step outside. The temperature is low. The ground is uneven. Food is not waiting in a refrigerator. Every calorie your body uses has to be found, hunted, collected, carried, processed, shared, and defended from scavengers. A body this heavy and active was expensive to operate. Researchers have estimated that Neanderthal daily energy needs may often have ranged from roughly 3,000 to 5,500 calories, depending on body size, sex, activity, climate, and the assumptions used in the model. That is a lot of food, but it is not automatically 7,000 calories every day, and it is definitely not a scientifically established 9,000 calorie minimum. Those giant numbers make excellent internet content. They are much harder to defend as universal biological facts. Even the lower estimates create a serious problem. How do you reliably feed a heavily built group through a cold season? For many northern Neanderthal populations, large animals were extremely important. Isotopes in their bones often place them at a high trophic level, with dietary protein coming mainly from herbivores such as reindeer, horses, bison, and mammoths. That does not mean every Neanderthal everywhere was a pure meat-eating hypercarnivore. Dental calculus, food residues, animal bones, shellfish, and other archaeological evidence reveal regional flexibility. Some groups consumed mushrooms, pine nuts, plant foods, birds, rabbits, tortoises, mollusks, fish, and marine mammals, when those resources were available. A Neanderthal living on a cold, open steppe did not eat exactly like one living near a Mediterranean coast or a forest in Iberia. They were not following a branded prehistoric diet. They ate what worked. Unfortunately, many of the foods that worked were capable of kicking them through a wall. Picture a hunting group moving through a winter landscape. They find fresh tracks. Ahead is a large animal carrying enough meat and fat to feed several people. It is also faster than them, stronger than them, and equipped with horns, hooves, tusks, or several tons of terrible attitude. The hunters do not charge one at a time while heroic music plays. They cooperate. They use terrain timing numbers and weapons. There is direct evidence that Neanderthals sometimes killed prey at close range. Fallow deer bones from Neumark Nord preserve wounds consistent with thrusting wooden spears. A cave lion from Germany appears to have received a lethal spear wound. That means some hunts became frighteningly intimate. A hunter might have been close enough to smell the animal, hear it breathe, and immediately regret every decision that brought him to that exact location. But Neanderthal weapons were not necessarily thrusting-only tools. Experimental work shows that Pleistocene wooden spears could be thrown effectively, and archaeological researchers increasingly warn against imagining a single, universal hunting method. They may have thrust spears, thrown them at short or moderate distances, ambushed prey, trapped animals against terrain, and changed strategies according to the species and location. They were hunters, not video game characters locked to one attack animation. An older popular claim says Neanderthal skeletons show an injury pattern almost identical to professional rodeo riders. It is a fantastic comparison. It is also far less secure than documentaries often imply. Neanderthals certainly suffered injuries. Many bones show healed trauma and close encounters with animals. Falls, harsh terrain, interpersonal violence, and everyday accidents all created risk. However, a large comparative study found that Neanderthals did not have a higher prevalence of skull trauma than Upper Paleolithic modern humans, once age, sex, and preservation were considered. So the accurate picture is not Neanderthals were repeatedly launched through the air by rhinoceroses. The accurate picture is still dramatic. They lived physically demanding lives where serious injury was common. Medical technology was limited, and recovery depended heavily on other people. A broken limb did not only test the injured person, it tested the group. Could they provide food? Could they protect someone who could not travel? Could they wait long enough for healing? The fact that many injuries healed reminds us that Neanderthal strength was not only located in individual bodies, it was also located in cooperation. Now we arrive at the feature people misunderstand most, the brain. Neanderthals often had very large cranial capacities. Some averages exceed those of recent modern humans in absolute volume. This does not mean they were automatically more intelligent. Brain size is influenced by body size, development shape, and the proportions devoted to different functions. A larger computer case does not tell you exactly what software is running inside it. Researchers have proposed that Neanderthals devoted more neural tissue to vision and body control because they had large bodies and lived at higher latitudes with difficult light conditions. That idea is interesting, but it remains debated and cannot be treated as a direct scan of Neanderthal thought. The archaeological record gives us better clues to what their minds could do. Neanderthals planned tool production. They selected stone from particular sources. They attached points to handles. They used fire. They processed animal hides. They made adhesives that required controlled steps. They used pigments, collected feathers or claws at some sites, and sometimes modified objects in ways that may have carried symbolic meaning. Their technology changed across regions and time, just as human technology does. They were capable of learning, teaching, remembering landscapes, coordinating dangerous activities, and maintaining social relationships. Calling them stupid is scientifically indefensible. Calling them identical to us would also be too simple. They were another human lineage with their own bodies, histories, populations, and ways of solving problems. So why did they disappear as a distinct population around 40,000 years ago? The easy internet answer is that Neanderthals were physically powerful but socially incompetent. They supposedly lived in isolated groups of 8 people, had no wider alliances, and were defeated by the superior social networking of Homo sapiens. Reality refuses to fit into one clean sentence. Genetic evidence does show that some Neanderthal communities were small. A group from Chagirskaya cave included close relatives and belonged to a small local community. Neanderthals also had a lower effective population size than modern humans, making demographic shocks more dangerous. Small populations can be vulnerable to bad seasons, low birth rates, accidental deaths, disease, and the simple mathematical problem of finding unrelated partners. But small does not always mean completely isolated. Genetic research, published in 2026, found that late Neanderthals in parts of Belgium and France showed more regional connectivity and diversity than some Eastern groups. The study found no evidence that steadily increasing genetic damage was the primary cause of their disappearance. That matters because it destroys another convenient myth. Neanderthals were not one failing population slowly collapsing everywhere in the same way. Their communities differed. Their environments differed. Their contact with Homo sapiens differed. Their disappearance was probably caused by several interacting pressures: low overall population numbers, climatic instability, ecological competition, disease, demographic chance, and absorption into expanding modern human populations. Not one final battle, not one superior invention, not one terrible winter. And not because every Neanderthal forgot to build a social network. Some of them did something far more important than defeat us. They became part of us. Modern genomic research shows that the ancestors of most people outside Africa interbred with Neanderthals. A major shared admixture event has been dated to roughly 45 to 49,000 years ago, although other encounters also occurred. Today, many people with ancestry outside Africa carry around 1 to 2% Neanderthal DNA on average. Some African populations also carry smaller amounts through later movements of people back into Africa. This does not mean 2% of your body is a tiny Neanderthal hiding inside your liver. Different people carry different fragments. Across the entire human population, those fragments preserve a much larger portion of the Neanderthal genome than any one person contains. Some inherited variants affect immune responses, skin biology, metabolism, pain sensitivity, and circadian timing. Some may once have been useful in new environments. Others are neutral. Others are associated with health risks. Many Neanderthal variants disappeared because natural selection removed them, or because random genetic drift erased them. And no, your Neanderthal ancestry does not automatically explain why you are strong at the gym. That is not how complex traits work. Muscle strength depends on thousands of genetic and environmental factors, including training, diet, sleep, age, hormones, injury history, and the uncomfortable possibility that another person simply works harder than you. But the genetic legacy changes the ending of the story. Neanderthals did not vanish without leaving descendants. Part of their history continued inside the expanding populations of Homo sapiens. Your workout finally ends. You put down the dumbbells, wipe the bench, and check your reflection one final time. The imaginary Neanderthal is gone. He did not break the equipment. He did not bench press a truck. He did not bite through a barbell. But for a moment, you understand what made his body extraordinary. It was not designed by a perfect fitness program. It was built through development, labor, climate risk, food scarcity movement cooperation, and a lifetime in which physical survival could never be separated from social survival. Neanderthals were compact, powerful, resilient humans. They hunted dangerous animals, endured changing climates, raised children, recovered from injuries, made complex tools, and occupied an enormous range for hundreds of thousands of years. Their bodies were different from ours. Their minds were not simple. Their extinction was not one clean defeat, and their DNA is not completely gone. So the next time you look into a gym mirror and feel like the final form of human physical evolution, remember the shorter figure standing behind you in the Ice Age snow. He does not need your pre-workout powder. He does not understand your fitness tracker. And he is still deeply confused about why you drove 3 kilometers to walk on a machine that goes nowhere. Neanderthals were not monsters. They were not failures. They were not primitive versions of us waiting to be replaced. They were one of the most physically remarkable human populations ever to exist, not because they could lift an impossible amount of weight, but because their entire way of life demanded strength, adaptability, intelligence, and cooperation every single day. That is what made them absolute freaks of nature.